So we're doing trig substitution right now, and the idea is to take advantage of the Pythagorean identities. So this one or this one to transform an integral. And in this example, this is a classic problem. We have a complicated thing inside of a square root, and we're trying to simplify that. So we want to take advantage of one of these identities to get that done. And what I see inside the square root is a constant minus a variable thing squared. And that's the sort of thing that could come from this first identity. So I could write down that cosine squared is 1 minus sine squared. And this piece, constant minus a variable thing squared, looks a lot like this. There's just some minor adjustments to make. So in particular, the 5 is causing problems. We need to get a 5 to factor out of the square root. So what I'm going to do is say, let x equal the square root of 5 times the sine of theta. The whole point there is that when I square that, I get 5 sine squared theta. And then inside the square root, I'll be able to factor out a 5, and I will be left with a 1 minus sine squared theta, which I know simplifies. So part of transforming the integral is always transforming the differential dx, and that's going to be root 5 cosine theta d theta. All right, so my original integral then becomes root 5 cosine theta d theta, all divided by the square root of 5 minus x squared, which was 5 sine squared theta. I can then factor out the 5. So when I do that, it would create a square root of 5 out in front of this radical, but that would cancel with this one. So I'm just going to take care of it all at once. And I'm left with a 1 minus sine squared theta in that denominator, in the square root in the denominator. Okay, so this one cleans up really nice. When I square root the cosine, I end up, or the cosine squared, I end up with just a cosine, which cancels that one. So I have just the integral of d theta, which is just theta plus c. And then to get the final answer, I've got to go back to the variable x that I started with. Solving for theta, here we go. Okay, so I get inverse sine x over root 5 plus c. And I want to point out with this problem that this is a problem we could have done with a substitution several sections ago, just recognizing the form of a derivative of an inverse sine. But I will tell you that in practice, being able to do trig substitutions is what should stick with you in the long run, rather than memorizing a formula for the derivative of an inverse sine. This is just way more powerful in the long run if you can see it as a trig sub and work your way through it.